there are two major ways of storing the data wherever we use in our database systems and whatever we are using, based on whatever application we are using, whether it's something like a consumer based app to store data, whether it's an application to store our logs of how our requests are performing. So one is SQL and one is NoSQL. SQL is like a librarian. It has the understanding of where the correctly labeled sections are. It is perfectly good for like when you have more organized data, like how a librarian knows how the where the which section has which book, what is the answer, whether this book is available or not. She can go and check. He or she can go and check, and he can and they can know an answer. It's a way of organizing the data. A SQL data is like that. And next is the best way to understand NoSQL is like delivery boxes. Specifically when we order something from Amazon or something like that, not every box, not everything is the same. Each and every box is different. Each and every box has a different package is a different thing. So we use the grab it, sort it, store it, and sort it later. It is best. This kind of database is best when you have messy and fast changing data, like Twitter or Instagram, social media apps to logs. Like not every log is the same. Every log comes in a few seconds, and both these databases are optimized for different purposes. So you should use SQL for when you have the same shape of data that's going to stay the same throughout the lifetime of your product, and NoSQL whenever you have a different shape, and each time it can be a different result, but it follows a small fixed format and it needs to be optimized for speed. Next, normalization. Write it once and use it forever. Let's take the example of an attendance register. So whenever we mark ourselves as present in a class, like a student is, so let's take the example that a teacher is writing down all the address of where the student is staying at each and every time she is logging it. Like whenever she is present or absent, his address is being logged down. So it's going to be repeated. It's going to be unnecessarily waste the time of the teachers, and it also invites mistakes. So one time if the teacher writes wrong, she'll just see the previous one and be like, okay, let's I think she'll also it leaves it prone to errors. And the biggest issue comes when a student moves. So now the newer data is going to be stagnant. So if someone wants to read it, it's till one point of the year it's going to be that a student was saying there, then it's going to be there's not going to be a huge issue. And this is just for one student. If someone decides to do this for like all the students, like 50-60 students in the class, then it becomes a huge headache. One way to solve this is something we call normalization. Basically we keep one list of names and one list of addresses, and we are linking that student's address to that address, the student's profile. So whenever we need to access the address where the user is, we just do a query we store the foreign key of the student inside the table, and then when we query it for this user ID, we get the address. Whenever we want to update it, we can just update this singular field, and we don't need to take into account of handling issues, redundancies, errors. So this is one way of doing this silly thing. And next is summary tables. So whenever we want, let's take the example of toys. A kid has many toys. He has a bear, he has a car, he has a robot, he has a dinosaur, and so much more. So the problem becomes that every toy needs, whether it's add or remove, needs to be locked forever. And in kids, how much people love kids, they buy them a lot of toys break, a lot of things go, and whenever the thing becomes to store such a mess, the issue becomes that how many toys are there, how much do they do, so how do we allocate space. So it's always a mess to store these kind of things. So we need to count everything and then see which type is which. We have to categorize it every time we store it. So the solution is, let's just add a whiteboard. Like this kid has 6 puzzles, 8 cards, and 5 dolls. and where whenever something gets added or removed, this gets updated, and there is only one way to know it. So let so basically we have that all these logs inside of our databases, but calculating each one of them, especially when you have large number of data like 100k records, something like that, every time your compute is going to be wasted, or it's going to be increasing every time that query is run. So like this is a famous case which happened with Instagram. So whenever Justin Bieber used to upload a photo, the Instagram used to go down because they didn't used to, every time the SQL query used to count all of it. So later they started doing a pre-counted version. So whenever, so this gets updated after a while, in cases like the Instagram example that I gave. But this is the only lookup thing we need to do, and this is the calculation that only needs to be updated when something gets added or something gets removed. So we are not querying the whole table, the whole data again and again, and we are saving a lot on compute every time. So that's all. I hope I was able to explain it